Hi friends, in this video we are going to discuss the most important topic in physics, and we can say it is the fundamental of the physics. That's units and measurement topic. We are going to discuss elaborately in this video. So we are gonna discuss five most important topics related to units and measurements. First one is international system of units, and then 7 SI base units, quantities and units, SI system, MKS, CGS, FPS system of units, and at last measurements topic discussing. So here they are given what is a unit. What is unit? The definition is given: an internationally accepted standard for measuring a physical quantity is called a unit. And there are two types of units. One is fundamental or basic units, and another one is derived units. Units that are used to express the basic amount or quantity are called fundamental units. For example, unit of length is meter and unit of time is second. The next type, derived units. The units which are obtained from fundamental units are called derived units. Example, unit of speed is meter per second. So, derived units is what which are obtained from fundamental units. So, fundamental unit is a basic, and with this basic the derived quantity had come. Next, what is international system of units? The international system of units is a modern form of metric system. It is globally accepted standard for measuring physical quantities like length, mass, time, temperature, and more. It was established in 1960 by the General Conference on Weights and Measures to ensure uniformity of measurements worldwide. So now we are using the International System of Units, that's shortly called as an SI systems. And why we are using is this unit only is globally accepted by everyone. Before this, we have few measuring units like FPS, CGS, and more, but that's not accepted by all. This is the thing. SI unit is globally accepted by the whole world, so we are using this, and it was established in 1960 by the Central Gen by the General Conference on Weights and Measures, and we are using this concept for the uniformity of measurement by all. The SI system provides a set of basic units from which all other unit of measurement can be derived. The International System of Units, it is the only system of measurement with an official status in nearly every country in the world. There are several SI systems used in physics that are used to express the different quantities. The quantities can be classified into two groups, that is base units and derived units. So we have discussed this earlier. This base units or fundamental units, and with this base units the derived units has arrived. And we have already seen the example for derived units, that is speed is equal to meter per second. And next, 7 basic units and the 22 derived units with special names and symbols may be used in combination to express other derived units. So in next slide we are going to see what of the base units and derived units. So this is the overview of the International Standard SI units. It is accepted globally and it is for uniformity. We are following this and it has two groups, that is base units and derived units, and we have 7 base units and 22 derived units. And what is the importance of this SI system? Why we need to follow this? It provides a standardized and universal method for the measurement all over the world. For this main reason and for this particular reason, we are omitting all the old traditional methods. We are avoiding because of this disadvantage of in uniformity in these measurements. So that for the uniformity, we are following the SI units all over the world globally. And its key importance, uniformity in measurement ensures that measurements are the same everywhere, avoiding confusion. And next is global acceptance, used internationally in science, industry, and commerce. Next, for the accuracy and precision, based on well-defined constants, ensuring reliable results. Easy for conversion, uses the decimal base 10 system, making conversions simple. Next, it has a scientific and technological development, essential for research, engineering, and communication across nations. Next, it has a foundation for derived units. All other units like Newton, Joule, Pascal are built upon SI based units. For this, 6 main reasons and its importance, we are using SI units. Okay, next. I have already told you there are 7 SI based units and 22 derived units. So here we discuss the base units. First one is meter. Its denotation is m, the unit of length. Meter is a unit of length. It measures distance or size. 1 meter is a distance light travels in vacuum in 1 by 2,999,792,458 of a second. So, how the meter is measured is given here, and meter is the unit of length. And next, kilogram. Kilogram is denotation as kg and is a unit of mass. It measures the amount of matter in an object. For example, you take an object, we don't know how much it holds. Maybe depending upon the weight, we measure that weight. How we measure? By using a gram, kilogram. So 1 gram equal to 1000 kilogram. By these measurements, we can know the amount of a matter in an object. What is matter? Anything which has mass and occupies some of its space is called matter, and that matter can be measured using kilogram. That is, kilogram is contains 1000 grams amount of matter in an object. This seconds. Second is a unit of time and is based on the vibration of cesium atoms and measures the duration or interval. Next, ampere. Ampere is a unit of electric current. It measures the flow of electric charge in a circuit. Okay. Next, Kelvin. Kelvin is a unit of temperature. It measures how hot or cold something is on an absolute scale. So we know temperature we can only feel. Okay, we can only feel the temperature, that may be hot or cold. Using Celsius and Kelvin, the temperature can be measured, and Kelvin is the unit of the temperature, and it used to measure how much hot or cold an object will be. And next is mole. MOL is a denotation of mole, is an unit of amount of substance. It represents 6.022 into 10 to the 23 particles, that may be atoms or an molecules. So amount of 1 mole is given here. Next is candela, CD representation, the unit of luminous intensity. It measures the brightness of light in a specific direction. So to measure the brightness of a light, candela is used and is a unit of luminous intensity. So here these are the 7 SI base units. And next we are going to discuss the SI system. We have discussed the base units briefly, and here the again the same SI units are given but with its symbol and SI unit. For length, for length, the S unit is meter and the symbol is M. Length is measured in meter. Length SI unit is meter. Mass, kilogram, kg. Time is measured in seconds. Yes. Electric current, flow of charges in a conductor, and this electric current is measured in ampere. Denotation is capital A. Um, so see, it's simple whether it is in capital or small, that is uppercase or lowercase. This denotation is very important in solving a numerical problems. So upcoming videos we are going to solve the previous year asked PYQ questions and creative questions related to this topic. So keep in mind the upper or lower case mentioned here is very important. Keep eye on it. Next, thermodynamic temperature is measured in Kelvin, capital K. Amount of substance measured in mole, small mol. Next is luminous intensity. Brightness can be measured in candela, CD. So these are the 7 base units or fundamental units in international system. Next, here the quantities and its units are given. So these are the very repeated questions in competitive exam in which every aspirants fail in this. Aspirants face difficulty in remembering this as they all remember the basic quantities like time in second, speed meter per second, like that. But here are the few difficult quantities which were not known by everyone. So please keep an eye on it. This is very important. So first we start with an angle. Angle is angle measured in radian, and angle unit is radian. Solid angle means steradian. Beyond force or weight, its unit is Newton or kilogram meter per second square, and its area measured in square meter, volume cubic meter. So these are the things we were seen in mathematics, and also in physics it is also important. Area means square meter, volume cubic meter, speed or velocity is unit is meter per second, angular velocity radian per second. So see, if the word angle is there, You just remember here angle radian. So here see angle means radian, velocity means there will be a time difference between them. So the seconds will be present. So radian per second. So study like this that will be more helpful for your upcoming exams and it keeps improve your knowledge. Frequency hertz, moment of inertia kilogram meter square, moment of inertia kilogram meter square. Next, impulse Newton second, impulse Newton second, angular momentum kilogram meter square per second. Pressure is measured in Pascal, its unit is Pascal, Newton per meter square. Power watt or joule per second square. So, friends, keep here they have given a comma, which means the pressure unit in question they can be mentioned in Pascal or in Newton per meter square, as well as power. They, in question they can give watt or in joule per second. Surface tension. So study both the things because we don't know which one unit will be given there. So remember both the thing. Next, surface tension, Newton per meter. Viscosity, Newton second per meter square. Heat conductivity, Watt per meter Kelvin. Magnetic flux, Weber. Displacement or distance in meter. Magnetic flux Weber. Displacement distance in meter. Next, work and energy, Newton meter or joule. Electric conductance, Siemens per meter. Deceleration, meter per second square. Entropy, joule per Kelvin. So see this deceleration entropy. We we have not studied these things in our day-to-day life, so we are not aware this. But these are the questions asked in competitive exams. So keep an eye on this. Daily analyze what you don't know. Put a test and see these are the questions will be there. Keep an eye on it. Entropy, joule per Kelvin. Specific heat, joule per kilogram. Electric charge, coulomb. Electric potential, volt. Resistance, its unit is ohm. Its formula V is equal to IR. We have studied from lower classes. Capacitance, Faraday. Inductance, Henry. Luminous flux, lumen. Wavelength, angstrom. Power of lens is measured in diopter. So few of the persons who wear specs, I hope you all know this. The power plus or minus. Um, in hospital they write in diopter unit only. So I have watched this. Intensity of sound in watt per meter square. Magnetic flux is in Tesla. Magnetic field is in Tesla. So see, magnetic field means Tesla. Magnetic flux means Weber. Okay. See these two areas. It will be a confusing part for you. Next, stress. Newton per meter square or Pascal. So this Pascal where we have seen it's also a unit of pressure as well as it's also a unit of stress. And Young modulus. It's also a unit of Pascal, Newton per meter square. Newton per C, the pressure. The same thing has repeated here but with different names. That is stress, Young modulus, and pressure. Next, radioactivity, becquerel. Radioactivity, becquerel. Density, kilogram per meter cube. Relative density has no unit, ratio of same quantity. So see this question has relative density has no unit. Strength of sound in decibel. Strength of sound is in decibel unit. Atmospheric pressure bar. Latent heat joule per kilogram. Astronomic distance light year or parsec. Gravity acceleration meter per second square, depth of sea fathom, ultrasonic speed Mach, gravitational constant Newton meter square per kilogram square. Okay, so I hope you have understood this. So I have given you shortly, but this is very important and these things only are asked in competitive exam this topic. Next we shall go for derived quantities and units and its physical quantity, symbol, derived unit and unit symbol. So area, symbol A, square meter, unit meter square. Volume, symbol V, cubic meter, meter cube. Speed or velocity, small v, meter per second. Acceleration, small a, meter per second square. So see how we should not read like m per a square. We should read like meter per second square. Okay. Keep an eye on this force. Capital F. The right unit is Newton and it's unit kilogram meter per second square. Pressure P. Pascal. P is equal to Newton per meter square. Energy or work has two symbol for work W and energy E. Both also have the same unit joule. J is equal to Newton meter kilogram meter square per second square. So in what are the places you see this hash symbol, you must think it's for a per. You should read as a per in reading the unit of a physical quantity. Okay, meter square per second square. Power P. Watt measured in watts. uh, Joule per second. Kilogram meter square. So what is this? That represents kilogram into meter square per, which is in division per second cube. Next, electric charge symbol Q, capital Q. Coulomb C is equal to A dot this, that is Coulomb equal to A dot S. Electric potential V, volt V is equal to W by A kilogram meter square. Per A dot H square. Electric resistance R ohm V by A. Frequency of Hertz 1 per second. Torque moment Newton meter Newton dot meter for density pro kilogram per cubic meter, that is meter cube. Okay, cubic meter means see here meter cube is the luminous flux phi. We call this as phi lumen. Next, illuminance E, that is lux. So see these two. For illuminance, derived unit is lux, and for luminous flux we have lumen. And next thing, other common units and conversions. Length, mostly it's not an SI unit. So see here, it's a non-SI unit. In length, the SI unit is meter, but it can also be measured in centimeter and in kilometer. But for length can be measured in. So I have already told you length can measured in meter according to SI. But if it is measured in centimeter using this particular term, it can be converted to a SI form. So here this is the conversion to SI unit. Okay, so centimeter and kilometer. If it is measured in kilometer, that kilometer into 1000 meter, we get an meter. Okay, 1000 meter is a kilometer. Next, mass gram 0.01 kilogram. So the SI unit of mass is kilogram. It can also measured in grams for a smaller object like gold, silver. For these objects, it is measured in grams only. For a greater object like ship and very heavy objects we measure in ton. So 1000 kilogram is 1 ton. And force can measure also in dyning 10 power minus 5 Newton. Energy ERG 10 power minus 7 joule. Pressure is bar 10 to the power PA. Pressure is SI unit is Pascal, but can also be measured in bar and also in ATM, atmospheric pressure. And here the formula for the conversion is given to an SI system. Temperature I have said to you, temperature SI unit is Kelvin, but it can also be measured in Celsius. To convert it into Kelvin, that's Celsius plus 273. Energy can be measured in calorie. These calories are measured in the body. How much calories are present, how much calories were burned during workout. And during such cases, energy